What did the V say when he was asked if he likes functions? Absolutely. Hey, boys and girls, welcome to our sixth and last video lesson in our first unit, 1-6, functions. Okay, a relation is a relationship between two variables. A relation is a relationship between two variables. A function is a special relation. It's a special relation between two variables such that for every x there is a unique y. So for every x value there is only one y value. There are four ways to represent a function. The first is an equation. The second is a graph. The third is an XY chart. That says chart. And fourth is what we call mapping, which we'll talk about, but we don't use it too often. Okay, so as we look at this equation right here, y equals x plus 3, we know that this is in the form y equals mx plus b, so we know that this is a linear function. The equation is right here. I know I can make some ordered pairs, okay, using an xy table over here, so go ahead, just plug those values in for x real quick. Okay, you should have found when you plug these in, we got 1, 2, 3, 4, and 5 when we plugged in neg 2, neg 1, 0, 1, and 2 respectively. Of course, our y-intercept is when x is 0, 0, comma 3, and that's our b, of course. All right, we can write that chart as a set of ordered pairs. There's my y-intercept. Okay, so we can write that as our ordered pairs. So that's, we have our equation. That's one way to describe a function. We have our table or ordered pairs. That's 2. Our third way to describe a function, of course, is the graph. So here's our linear graph, y equals mx plus b, y equals x plus 3, y-intercept of 3, and a slope of 1. There's our graph. And we can also do mapping. And all mapping is writing our ordered pairs with arrows going from the x to the y. So I can write here, if I want to, I can write, for example, 1, comma, or 1 arrow 4. I can write 3 arrow 6. I can write neg 2 arrow 1, etc. So there's a mapping. That's our fourth way to describe a function. One way to look at the graph of a relation and to decide is whether it is a function or not is employ what we call the vertical line test. So for example, this blue line right here, it's a relation, it's a bunch of ordered pairs, it's a relationship between x and y, but it is clearly not a function because it does not pass the vertical line test. If I take a vertical line, in this case this green line, and put it anywhere on my function, if at any time it passes through the graph more than one time, so in this case it passes through 3 times, for every x value right here, there is more than one y value, so it is not a function. However, this red line would be a function because no matter where I draw a vertical line, it always passes the vertical line test. In other words, it only passes through the graph one time. Okay, let's talk about some families of functions. This is muy importante, just so you know, muy importante, very important in Spanish. One of our functions that you already know about are linear functions. Y equals mx plus b. If I were to graph that, of course, y equals mx plus b looks something like that. It could be anything, depending upon what our m and what our b is. A special type of linear function is the constant function. We'll do this in blue. A constant function we know is a horizontal line. It's the equation y equals b. A direct variation function is when the b is 0, the y-intercept is 0, so it passes through the origin. The equation is y equals mx, and it might look something like this. And then there's a very special function, and we'll talk about this, the importance of this later. It's called the identity function, which is y equals x. That's a direct variation function. It passes through the origin, but its slope is also 1. Y equals x. All of these functions that you see right here are all examples of linear functions. Constant functions, direct variation functions, and the identity function are all special cases of linear functions. Please make sure you get these down into your notes. You also need to know about quadratic functions. Quadratic function in general form, y equals ax squared plus bx plus c. Quadratic functions in vertex form is in the form y equals a times x minus h squared plus k. Our next unit, unit 2, is all going to be about quadratic functions, but you need to know right now when you graph a quadratic function, it makes a parabola. I think you probably know that. Our absolute value functions we just went over. In vertex form, of course, it is y equals a times absolute value x minus h plus k, and it makes a v, of course. And maybe, we'll talk about these, but maybe not. Greatest integer functions are going to be a series of steps. We call this sometimes a step function, and we'll talk more about those later, possibly. All right, please make sure you get these down into your notes. Okay, a couple more words you need to know. A continuous function is a function that when you graph it, you can graph the whole function without picking up your pencil. In other words, it has no breaks, it has no holes. This is an example of a continuous function. A discrete function is a function that's not continuous. So in other words, it has breaks. Like right here, there's a break. Right here, there's a break. And when you graph the function, it might jump from one place to another place. All right, two more very important words you need to know. The domain of a function is the set of all possible inputs, or the x's of a function. It's the independent variable. When you graph a function, the independent variable will always be on the horizontal or the x-axis. It's the x variable. It's the input. It's where we start. The output of the function is called the range. It's called the range. It's the dependent variable because it depends upon the independent variable. What comes out depends upon what you put in. The output is the y. It's the vertical axis when we graph them. It's the y variable. That's the range. Okay, as we look at this set of 5 ordered pairs, this is a relation. It may or may not be a function. Let's see. But we're going to state the domain, the range, and show the representations with a table, a graph, and a mapping. We don't know the equation yet, but let's figure out the domain. The domain is going to be all the x's, so that's going to be neg 4, neg 2, 0, 1. And then we have neg 2, but we already have it 1, so let's not write that twice. So our domain is neg 4, neg 2, 0, and 1. Our range is going to be the y, so that's going to be 3, 1, 3 again. We don't need to write it again. So we have 3 again. Let's just not write it. We got neg 2, and we have neg 4. If I make an xy table, I can do that. I have neg 4 and 3. I have neg 2 and 1, 0 and 3, and 1 and neg 2, neg 2 and neg 4. If I were to plot these points, I have neg 4, 3. So that's going to be right about here. I'll do my best. We have neg 2, comma 1. That's right here. I'm doing my best here. I have 0, comma 3. That's going to be right here. I have 1, comma neg 2. That's here. And I have neg 2, comma 4. Right here. So I can already see now that this is not a function because it does not pass the vertical line test right here. In other words, for when x is neg 2, there are 2 outputs. A function must have a unique output for every input. So for every x, there must be one and only one y. In this case, when x is negative 2, we have 2 y's. So this is not a function. If it were a function, this would be a discrete function because it's not continuous. Okay, the mapping of this now would look something like this. I'm going to draw. Let me get my marker back. I'm going to draw some bubbles. Okay, I'm going to have my x's, which is neg 4, neg 2, 0, and 1. Of course, negative 4 maps to 3. Negative 2 maps to 1, but it also maps to -4, and that says that's not a function. 0 maps to 3. And 1, of course, maps to -2. So there's our mapping. So now you can see now we have all the different ways that we can describe a relation except for the equation. There is no equation that matches this graph. But we have, our domain and range. We have a table. We have a graph. Interesting graph. And we have mapping. Okay, function notation. This is very important. And I remember when I was a kid, this at first frightened me. It confused me. One way we can write a function is with two variables, x and y. The other way we can do about it is think about as y, we replace y with what we call f of x. Now this is not multiplying. This is not f times x. This is what we're saying, it's a function of x. So y is a function of x. So we can write y equals 2x plus 3, which is a linear function. We can also write that this means the exact same thing, f of x equals 2x plus 3. So x is our x, and y becomes f of x. So if I say to you, evaluate y equals 2x plus 3 when x equals -2, what would you do? You would take x and replace it with -2. You would replace x with -2 and get y equals -4 plus 3, which is -1. The exact same thing that you can say now in function notation, given f of x equals 2x plus 3. Find f of -2. What this is saying is replace x with -2. Find the value of the function when x is -2. So we do the exact same thing. We plug in -2 for x and we get -1. Given f of x equals 2x plus 3, find f of -2 means the same as y equals 2x plus 3. Find the value of y when x is -2. These mean the same thing. So if I have a linear function, why do I know it's a linear function? Because it's in the form y equals mx plus b. It's a linear function. I can write that in function notation. F of x equals 3x plus 7. If I say find f of -1, what I'm saying is just plug in -1 for x. Down here in green, I have an absolute value function. I know it's an absolute value function because it's y equals a, x minus h, and then there's a plus k here. K is 0, but this is an absolute value function, which of course makes a v. F of x equals -2 times x minus 2. Find f of -1. That means just plug in -1 for x. So go ahead and find those two values, f of -1 for both the blue and the green functions. All right, I'm hoping you got 4 for the linear function. F of -1 is -3 plus 7, which is 4. And of course, in the absolute value function, when I plug in -1, I get -1 minus 2 is -3. Absolute value of -3 is positive 3. -2 times positive 3 is -6. Okay, you guys try these. Find the domain and range of the following just looking at the graphs. We got the graphs of these three functions down here written in function notation. This, of course, is a quadratic function. It makes a parabola, and it's an x squared. We have a square root function, which makes this kind of little shape right here. And we have actually a third power function, f of x equals x to the third. I want you guys to find the domain and the range for each function. Give it your best shot, and we will go over it in class mañana. That's it, folks. Have a great night, and we shall talk to you soon.